Welcome to this comprehensive introduction to Python programming. In this series, we'll explore Python from the ground up. Perfect for beginners and a great refresher for experienced programmers. Let's start with the basics. What exactly is Python? Python is a versatile, high-level programming language created by Guido van Rossum and first released in 1991. Interestingly, it's named after the British comedy series Monty Python's Flying Circus, not the snake. Python stands out for its clean and readable syntax that almost looks like plain English. There are two major versions, Python 2 which is now obsolete, and Python 3 which we'll be using in this series. Python's versatility makes it perfect for everything from web development to artificial intelligence. Its extensive standard library and thriving ecosystem mean you can find a package for almost any task imaginable. Now you might wonder, why should I learn Python among all programming languages? Python has become one of the most popular languages worldwide. And for good reason. First, Python is incredibly beginner-friendly with syntax that reads like English. It has an extensive collection of libraries for any task imaginable. Major companies like Google, Netflix, and NASA use Python extensively. It's equally great for beginners learning programming concepts and experts building complex systems. Plus, Python skills are in high demand with one of the strongest developer communities supporting it. Let's dive deeper into Python's key features that make it stand out from other languages. Python is an interpreted language, meaning it executes code line by line, which makes debugging easier. It's dynamically typed, so you don't need to declare variable types. Python runs on all major operating systems without modification. It supports multiple programming paradigms including object-oriented, functional, and procedural programming. The Python ecosystem boasts massive libraries like NumPy for scientific computing, Pandas for data analysis, and scikit-learn for machine learning. Now that you're excited about Python, let's get you set up with the tools you'll need. First, download Python from python.org. I recommend Visual Studio Code as your code editor. It's free and has excellent Python support. For data science work, consider installing Anaconda, which includes Jupyter Notebook. After installation, verify Python is properly set up by opening a terminal and typing Python version. The links shown on screen will help you get all these tools installed. Let me walk you through running Python code in Visual Studio Code, one of the most popular editors. After installing both Python and VS Code, you'll want to add the Python extension from the VS Code marketplace. Create a new file with a py extension to write your Python code. You can run it directly in VS Code using the terminal with the command Python, followed by your file name. VS Code offers excellent debugging tools, set breakpoints, inspect variables, and step through your code line by line. For data science and interactive computing, Jupyter Notebook is an invaluable tool. Jupyter Notebook provides an interactive environment where you can mix code, visualizations, and narrative text. Install it using pip or through Anaconda. Launch it from your terminal with Jupyter Notebook. The browser-based interface lets you create notebooks containing executable code cells. This is perfect for data exploration, prototyping, and sharing reproducible research. You can execute cells independently and see results immediately below each cell. Now let's dive into Python's syntax fundamentals. We'll start with the most basic Python statement, the print function. Here's the most basic Python statement, printing, hello, world, to the console. The print function outputs whatever text you put inside the parentheses. Notice how simple and readable this is compared to many other programming languages. Now let's see how to use variables in Python. Here we create a variable called name and assign it the value, Alice. Then we use an f string to print a greeting. F strings, introduced in Python 3.6. Make string formatting very intuitive by allowing you to embed expressions directly in string literals. Python has several ways to handle multi-line statements. Here we use parentheses to break a long mathematical expression across multiple lines. The indentation after the line break is optional but improves readability. Python also allows using backslashes for line continuation, but parentheses are generally preferred. One of Python's most distinctive features is its use of indentation to define code blocks. Unlike other languages that use braces or keywords, Python uses whitespace to structure code. Here's a properly indented for loop in Python. The colon at the end of the for statement indicates the start of a code block. And the indented print statement is part of that block. The standard Python style guide recommends using 4 spaces per indentation level. Now look what happens when we remove the indentation. This code will raise an indentation error because Python expects the print statement to be indented to show it belongs to the for loop. This strict enforcement of indentation is why Python code is consistently readable. Comments are essential for explaining code and making it more maintainable. Python provides 2 ways to add comments to your code. Single-line comments start with a hash symbol. Everything after the hash on that line is ignored by the Python interpreter. These are great for brief explanations of complex code. For longer explanations, Python supports multi-line strings enclosed in triple quotes. While not technically comments, when used at the start of modules, functions or classes, they serve as doc strings that can be accessed programmatically. Let's look at some basic Python syntax to get a feel for the language. Here's a simple Python script demonstrating basic syntax. We see a print statement outputting, hello, world, single quote, a list of fruits being printed, and a dictionary storing information about Python. Notice how clean and readable the syntax is. The output shows exactly what we'd see if we ran this code in a terminal. Python's versatility makes it useful across countless real-world applications. Python powers web applications through frameworks like Django and Flask. In data science, libraries like Pandas and Matplotlib are industry standards. Machine learning thrives with TensorFlow and PyTorch. Python automates repetitive tasks with tools like Selenium. Even game development is possible with Pygame. In healthcare, Python helps with predictive diagnostics and medical research. These are just a few examples. Python's applications are truly limitless. Python opens doors to exciting fields like artificial intelligence, web development, and automation. In this series, we'll guide you through Python step by step using the latest version, Python 3.11. Whether you are looking to start a career in tech, automate boring tasks, or explore data science, Python is the perfect language to learn. First, let's begin this exciting journey together.